For the given network, determine all currents. Okay, so in this circuit we are going to have three currents. We are going to have total current, I total. We are going to have current which will go through resistor R1, so this is going to be my I1, and current which will go through resistor R2, I2. Please notice that in parallel circuit, the voltage source is connected directly across each resistor. So it means that voltage across each resistor is going to be equal to the voltage source. Okay, so I can say that V1 is equal to VR1. This is also equal to VR2. Okay, voltage source is equal to the voltage across resistor R1, and this is also equal to the voltage across resistor R2, and this is equal 9 volts. Okay, so if you want to find the current which goes through resistor R1, simply use Ohm's law. I1 is equal VR1 over R1. VR1 is equal 9 volts over 910 ohms. Okay, so this is equal, it's the calculator, 9 divided by 910. Okay, please notice that this time I do not see K, that's why I do not use the function exp. Okay, so this is equal 9.89 milliamps. Okay, so this is the current which will flow through the resistor I1. Next, I suppose to find the current which will go through resistor R2. So I have I2, or we can say I2 or IR2. Okay, in some books we are going to find IR1. So this is equal VR2 over R2, where VR2 is equal 9 volts over R2, which is equal 470 ohms. Okay, this is equal 9 divided by 470. Okay, this is equal 19.14 milliamps. Okay, so we found I1, we found I2, and now we can use KCL, Kirchhoff current law. Okay, KCL for parallel circuit, and simply write that I total is equal the sum of these two currents, I1 plus I2. Okay, we can also say this is IR1 plus IR2, depends from the book. So we have 9.89 milliamps plus 19.14 milliamps. Okay, I'm going to use the calculator just to practice, because many people fail the test because they don't know how to use the calculator. My calculator can be a little bit different than yours, but the concept is the same. You're supposed to find the exp function, or sometimes on your calculator you are going to see EE function, and use it anytime you are going to deal with the prefixes, okay, with the engineering notation. So I have 9.89 exponent -3 plus 19.14 exponent -3. This is equal 29.03 milliamps. Okay, so this is one way to get I total. Okay, but let's say we want to verify if our answer is correct, if our answers are correct. Sometimes someone can say, Okay, so how come I know that whatever I did is correct? Simply find R total. Okay, find total resistance. Total resistance, okay, we have two resistors. That's why I'm going to use product over the sum. R1 times R2 over R1 plus R2, where R1 is equal 910 ohms times 470 ohms. Divide 910 ohms plus 470 ohms. Okay, this is equal, and I have 910 times 470 equals, divide by open parenthesis, 910 plus 470 close parenthesis. This is equal 309.92 ohms. Okay, and again, please notice that the total resistance, okay, in our circuit, parallel circuit, is less than the lowest resistance in the circuit. Okay, so 309 is less than 470. Okay, so it looks that we are doing everything fine. So next I'm going to find I total. I total is equal voltage 1, because my circuit, okay, has voltage source labeled V1. V1 over R total. V1 is equal 9 volts. 9 volts divided by 309.92 ohms. Okay, so we have 9 divided by 309.92. Okay, so this is equal 2904 milliamps. 29.04 times 10 to negative 3. So this is 29.04 milliamps. Now we're supposed to compare this I total with this one which we got before. Okay, as you can see, these two values are almost identical. Okay, the difference is so small, so we can say that we found the values of the currents in the circuit, and they are correct. So I1 is equal 9.89 milliamps, I2 is equal 19.14 milliamps, and I total is equal 29.04 milliamps. So we can say that the problem is solved.